Okay, so now we're going to look at Orr's theorem. And Orr's theorem starts off with you have a connected graph. So let G be a connected graph of order greater than or equal to 3. Then, where UV, which is not an element of the edge set, in other words, all the non-adjacent vertices have the degree of U plus the degree of V being greater than or equal to N. What this does is all the non-adjacent vertices in this graph will suddenly be connected for the closure. So there's a specific condition which says all the non-adjacent vertices are such that their degree of U plus the degree of V is greater than or equal to N, and that means that all the non-adjacent vertices are suddenly added to the graph's closure. Then G contains a Hamiltonian cycle. And let's just write that way neater. Hamiltonian cycle. So what this is actually doing is, again, very carefully, where the U and V are not an element of the edge set, in other words, where all the UV non-adjacent pairs fit the condition where you add it to your closure. So in other words, fit that du plus dv is greater than or equal to n, which means your closure is your original graph plus all your non-adjacent vertices, however many you have them. And if that is the case, so if all your non-adjacent vertices are suddenly inside your graph, that's actually going to give you a complete graph. So let's just go ahead and prove it. Okay, so the proof of this is actually pretty straightforward because you're basically going to use the idea that if CG is Hamiltonian, then G is Hamiltonian. And it's written in such a way that, you have your UV is not an element of the edge set, but every UV is such that some of its degree is greater than or equal to n, which means you add it into your graph of your closure, which gives you your closure of your graph is actually a complete graph. So you can utilize what you know about complete graphs. So all complete graphs are Hamiltonian. So you have your CG is Kn, but your Kn is Hamiltonian, and therefore G is Hamiltonian because CG is Hamiltonian. Go check that your complete graph is Hamiltonian.